All right, so today we are going to decompose and compose fractions greater than 1, and we're going to try to express them in some different forms. So let's start with the fraction 7/3. What do you notice about 7/3? Hopefully you said something like it's greater than 1. It's an improper fraction. The denominator is 3. The numerator is larger than the denominator. Those are all good. Now, looking at the denominator, how many thirds make one whole? So, the question is, how many thirds equal one whole? The answer is 3/3 equals one whole. So count by 3, or count by thirds. So 3/3, 6/3, 9/3. Stop. We only have 7/3. So we're going to decompose 7/3 using a bond to show 6/3 and the remaining fraction, because when we were finding multiples of 3, it's kind of like when we were doing division. We definitely have 6, but we don't have 9. We only have 7. So here, we can have 6/3 because we counted 3/3, 6/3, 9/3. We do have 6/3 here, and we have a remaining 1/3. So 7/3 equals 6/3 plus 1/3. Now we need to rename this using whole numbers and fractions. So here, just looking at 6/3. Using your fingers, count by thirds. 3/3, 6/3. How many fingers do you have held up? 2. 2 whole fingers, because 6/3 is 2 whole pieces. Now, if we were to add 1/3 onto that, that is a fraction less than 1, so we just put it next to our whole number. Add 1/3 to 2. So 7/3 decomposed and then recomposed. Decomposed, and then we composed it into a whole number and a fraction. So we started with an improper fraction. We decomposed it into a fraction that was equivalent to whole pieces, and then some extra. And then we composed it into a mixed number. Now this is using addition. We can also do the same process using multiplication. So let's start with the same fraction, 7/3. And we are going to decompose this using multiplication. We found out that there are how many whole pieces? So we found that 3/3 equals 1 whole. We counted by thirds and found that there are 3/3 and 6/3. So we found that 2 groups of 3/3 are in 7/3. Or we can get 3/3 2 times. That's our first step. When we get 3/3 2 times, we would have 1 left over. On the outside here, we would have 1/3 left over. Doing what is in the parentheses first, always, we can solve just like we did the other day. 2 times 3 equals 6. Keep our denominator the same. And we still need to add the 1/3. Now, if we do this, we are going to end up with 7/3, which is a problem. We don't want 7/3. We started with 7/3. So before we use that multiplication, what is 3/3? 3/3 is equivalent to 1 whole. So really, instead of 2 times 3/3 here, we have 2 times 1. 2 times 1 equals 2. And we still need to add our 1/3. So in total, 2 plus 1/3 equals 2 and 1/3. Now let's do one more with multiplication. Let's start with 10/4. And ask yourself, how many fourths equal 1 whole? Four fourths equals 1 whole. So now we should count by fourths. 4/4, 8/4, 12/4. Went too far. We only have 10. So 4/4, 8/4. So counting by fourths, we have 4/4 2 times here. Group that up. Now we counted out 4/4, 8/4. What is the difference between 8 and 10? We would have a remaining 2/4. Here, we see that 2 times 4/4, 4/4 is equal to 1 whole. So we have 2 times 1 equals 2. We need to add our 2/4. And 2 plus 2/4 equals 2 and 2/4. Not too bad. Now we can check our answer here to make sure that we have, let's do a new slide. To make sure that we have set it up right. Now if you're really concerned and you're wondering, did I set this up right? Which new topic, you should be concerned if you set it up correctly. So we counted by fourths, 4/4, 8/4, 12/4. 4/4, 8/4. So we found that 2 4/4 pieces go in here. We said that there are 2 extra pieces. So let's just focus on what is in parentheses right here. We learned how to multiply this out. 2 times 4 equals 8. Keep your denominator the same. We need to add on 2/4. Now we can add our fraction, 8/4, which is the same as 2 times 4 over 4, just like we did here. Multiply 2 times this 4. Keep your denominator the same. 8/4 plus 2/4 equals 10/4. So before you multiply out, if you're a little uneasy, you can always check to see if you've done it right by just solving still in the improper fraction, looking at if you got this part correct. Not too bad. It's now we're into the stage where we count by 1/2 pieces to see how many 1/2 pieces go into our improper fraction. Alrighty.